Okay, today we have learned about this chemical and physical reactions, if you can remember the chemical changes and the physical changes. So then we have discussed about few of these experiments last day. So using our presentation, just discuss how different things react, and so whether it's a chemical or physical reaction. The physical reaction, basically, you will not see any new compounds or any new substances or the compounds after the reaction. Still there will be the same composition, but in the chemical reaction there will be new substances and new formats, new solutions. Those things will be there after the reaction. So that is the thing. Okay, we have learned about that last day. Now let's continue. And here you can see a copper. So this experiment, there are a few experiments. I am not sure whether we have discussed this. Let me go to my PowerPoint presentation. Did we discuss this copper sulfate iron nailed and boiling tube? This one. So copper sulfate, the crystals. Yes.
Yes, sir.
We have discussed, right? Okay. Wait. I think. Yeah, here. 12 or 19. This one. Okay, let's just discuss. I'm not sure whether we have discussed this last time. Okay, copper sulfate, iron nail, and boiling. What is the result when you put the copper sulfate and then the iron nail into this solution in the boiling tube and a thermometer? What you need to do is add water. Right. First of all, you need to add copper sulfate and water. Copper sulfate is basically crystals are in blue color. Then, so it will create a light blue solution. So then put cleaned iron nail into it. And so what will be your observation? Right. So then, yes, what you can see. Yes, copper sulfate and iron nail. So what will happen? If you keep it for some time, right? Then you can see copper. Copper will be like copper, the reddish brown substance will deposit. That is actually copper on the nail. And at the bottom, white, and the bottom, while the temperature rises. If you measure the temperature rises because there is a reaction and reddish brown substance deposit on the nail. So there will be reddish brown substance deposited. That is actually copper. And then the blue color solution decreases. The color of the blue solution or the blue is this because copper sulfate, there is sulfate and copper. But when the copper ions reduces, then the copper sulfate solution will not get that color. So the color will be reduced. So that is one thing. And again, a solution of copper sulfate and solution of sodium hydroxide. Then you have to mix both, and there will be a blue color, kind of a blue color solid. What is that? Yes, that is called like actually precipitate. Precipitate, such solids are called precipitates. So what will happen? So copper sulfate and sodium hydroxide. Yes, I think we discussed about the reaction too. I'm not sure which presentation we have used. That is the problem. Actually, I cannot remember the presentation that we have used, but This is a way back we have discussed about this. This. Not even this. I'm not sure where I have saved this. I'm really sorry for that. I'm not sure where I have saved, but I have just, I think I have displayed this. Anyway, let me go to the video, previous video, and come back to that. But before that, let's discuss. So then the copper sulfate solution with sodium, copper sulfate solution with sodium hydroxide solution will create a blue color solid. Right, then dilate hydrochloric and the zinc. So hydrochloric will react with zinc and you can observe bubbles, right? So zinc will be dissolved and you can observe some bubbles and new substances will be formed. So these kind of things we'll call chemical reaction. So actually what you can see in chemical reaction, emission of a gas or evolution of a gas, or you can see change of color, change in temperature. So it can be like increase or decrease. Formation of precipitates, avakshepa කියලා කියන අපි හැදෙන ඒවා නිකන් කණයක් හැදිලා මේව වෙනවනම්, so formation of precipitates. Then production of sound or light, so that can also be, and production of odor, සුවඳක්, ගන්ධයක් ඇති වෙනවා වෙන්න පුළුවන්, right? Those things are the results when there's a chemical reaction. These kind of things can be observed. Actually, now I think we need to know about the physical reactions and chemical reactions. So this is a magnesium again. So magnesium, when you burn it in the environment, it will create magnesium oxide, the white color dust, right? And there will be bright, right? There will be bright. Just that. Right? So these are the things that we have learned, that we have discussed last day. Let's discuss about law of law of conservation of mass. Skandha Sansthiti. Law of conservation of mass. Okay, so to experiment this, we are going to use iron wool. Why iron wool? Because it is easy to burn that. Iron wool can be burned easily. Then two identical iron wires, a horizontal rod. Actually, you can use a ruler or something to like balance this. You have to balance both sides, two identical wires and also iron wool. So then you have to take equal masses of iron wool and lump them loosely. Here you can see there's one lump and there's another lump. And so these are equal in size. So this rod should balance, right? The horizontal rod should balance because the sizes are equal. And then suspend the rod, right? You have to use iron wires. Otherwise, if you use like thread or something, නූලක් වගේ use කරොත් බෑ, එක පිච්චිලා යනවනේ. එහෙනම් මේකට මේ යකඩ වයර් එකක්ම මේව එකක්ම ගන්න ඕන. වයර් එකක්ම ගන්න ඕන. කම්බියක්ම ගන්න ඕන. නැත්නම් මේක පිච්චිලා යනවා. එහෙනම් මේ දෙකට යකඩ කම්බි දෙකක්, මේකේ අයන් වූල් කියලා කියන්නේ නිකන් අර ගොඩාක් තුනී කම්බිත් නොවන මට්ටමේ ගොඩාක් තුනී අයන්. එහෙම එක් ගන්න පුළුවන්, කඩවල තියනවා ගන්න. You can use that, and then what you need to do, you have to burn one, right? So when you suspend the rod and balance horizontally, light one lump of iron wool. So you have to light one lump of iron wool, and what will be the result? එකක් රත් කරොත්, දැන් එකක් හොඳටම රත් කරනවා. කරනකොට මේක පිච්චෙනවනේ, පිච්චිලා යනවා iron wool එක උනත් ගිනියම් වෙනවා. රතු පාට වෙලා ඒක ගිනියම් වෙලා පිච්චෙනවා. So what will be the result? Right? What will be the result? Burning, let me show. Iron. See here. steel wool or iron wool. When you see it burns, so you can see what has happened. When boiling the iron ore, it has fallen down. But when boiling this iron ore, it has fallen down. එක පාත් වුණා. හේතුව මොකද්ද? මේක පාත් වෙන්න නම් හේතුව මොකද්ද? මේකේ බර වැඩි වෙන්න ඕන නේද? Can you hear me? No?
Yes, sir.
When you do the experiment also, you can see that result. මේක රත් වෙලා ගිනිගෙන මේ වගේ burn වෙලා ඉවර වෙනකොට මේ පැත්ත පාත් වෙනවා. ඇයි මේ බර වැඩි වෙන්නේ? What's the reason? ඒ ස්කන්ධ සංස්ථිතියේදී කියන්නේ පුතේ ප්‍රතික්‍රියක නැත්නම් ප්‍රතික්‍රියා කරන ඒවා reactors. ඒ react කරන ඒවායි හැදෙන ප්‍රතිඵල results. මේ දෙකේ බර සමාන වෙන්න ඕන කියන එක තමයි මේ කියන්නේ. react කරනකොට තිබ්බ එකයි result එකේ බර සමාන වෙනවා. කියන එක තමයි අපි කියන්නේ මේ mass conservation කියන එක. ස්කන්ධ සංස්ථිති නියම. law of conservation of mass. හරි දැන් මොකද උනේ බර්න් කරාම මේක පාත් වුණා. ඒ කියන්නේ බර වැඩි වෙලානේ. ඇයි මේ බර වැඩි උනේ? එතකොට ස්කන්ධ සංස්ථිති නියමයේ බොරුද? Is it a false law? Law of conservation of mass. Is it a false? So why the weight has increased? So what do you think? ඔයා හිතන එක කියන්නේ. Yes? Hello? When magnesium burn කරාම මොකද උනේ? Magnesium burn කරා. කලින් නේද මේ? Magnesium, when you burn this, when you light this, or when you burn this with oxygen, when you react this with oxygen, actually what you need to do, here, similarly, you can see the magnesium. When a magnesium sprite is burned, it will react with oxygen. See here, it will react with oxygen. So this is magnesium sprite. When you use a Bunsen flame, and then when you try to burn this, see what will happen. It will emit a bright flame, a bright light. And there will be white color dust, that is magnesium oxide. See here. Okay, it burns. See, it's really, really bright, right? And after burning, so this is what remain. It is like, you can keep it in Petri, this. Okay. You can see it forms white color, ash-like. That is magnesium oxide. Okay, so think about that and tell me what will happen when you are burning this iron wool. Iron wool burn කරද්දී මොනවා වෙනවද? Yes? Hello? Can you hear me or cannot?
Can, sir.
So is it clear to you, or like is it difficult to understand? Magnesium. දැන් හිතන්න එකක් ගැන හිතලා අනිත් එක කියන්න පුළුවන්. Magnesium රත් කරද්දි මොකද උනේ? So when you burn magnesium, what has happened? It has connected with oxygen in the environment, then created magnesium oxide, right?
Yes.
What is the color of magnesium oxide?
White.
So is it a chemical reaction or physical reaction?
Chemical.
So why it is chemical reaction?
It produces new substance.
It produces new substance. How you know? Right? What are the things to see? So is it evolution of gas or emitting of gas? Change in color. Is it happen? Change in color. Magnesium was it's like kind of aluminium stripe. It looks like that. But after burning, you can see white color ash. Right? Means change of color has happened. Then any light or sound? Was there any light or sound?
Yes, sir.
Yes. It has produced a bright light, a bright flame, bright light. Therefore, this has happened. So you can decide that as a chemical reaction. So now, what has happened when you burn magnesium in air? It has reacted with oxygen in the air and created magnesium oxide. So when you burn this ferric or this iron wool in the environment, so what will happen? Similarly, it will react with oxygen and it will create ferric oxide. Right? It will create that. So that is what happened. Right? When you burn this in the environment, in the air, here, burn iron in burn iron in air, what will happen? It will react with oxygen, and as a result, here when you're burning this in air, this is what you have seen. But what will really happen chemically? Chemical reaction is, so can we see the chemical reaction somewhere? No. See chemical reaction. So still I think you will not be able to understand the symbolic notation, but try to read the word. Iron will react with oxygen and will create iron oxide, sometimes called ferric oxide. Right? Sometimes called ferric oxide. Right here, because this is ferric, no? So Fe is ferric. So then this is what happened in the reaction, iron 2 or iron 3 oxide. Right? So here it's called ferric oxide. All right. This is what happened, ferric oxide. So ferric oxide is in red color. And that is sometimes called iron 3 oxide. Iron 3 oxide or ferric oxide. Right? Both are okay. Right. So then why this will come down? This has same, like let's say this has X grams. And this is also X grams. So both are equal. But after burning, so here you have ferric, Fe. After burning, it has created ferric oxide. And it has come down. What's the reason? Now it's not the same mass. It's not same mass now. එකම බර නෙවෙයි. හේතුව මොකද්ද? කොහෙන්ද මේ අලුත් බරක් ආවේ? Yes. Can you hear me?
Yes, sir.
Are you listening to me? Right, then tell me how the new mass, like how this has increased. So මොනවාද දැන් වැඩිපුර තියෙන්නේ? දැන් මෙතනත් ferric තියෙනවනේ. තව මොනවා හරි වැඩිපුර තියෙනවද?
Oxygen.
Oxygen. අතර ferric එක තව එකක් තියෙනවා. ඒ තමයි oxygen. Fe2O3 කියලා මේක ලියන්නේ. හැබැයි මේකම දැනගන්න අවශ්‍ය නැහැ දැම්මම. හරි දැන් මේ chemical මේ symbolic notation එක ඕනේ නැහැ. හැබැයි නිකන් මතක තියාගන්න ferric oxide නැත්නම් iron trioxide කියලා අපි කියනවා. ferric oxide iron trioxide කියලා කියන්නේ oxygen මෙතන තියෙනවා. So the like increased weight came from the oxygen. හරි එතකොට මට කියන්න is this false then? Law of conservation of mass.
No, sir. True.
Then mass should be when starting and ending of the reaction, the masses should be equal, no? According to this law of conservation of mass. Yes.
Sir, burn කරපු නැති එකේ තියෙන්නේ iron විතරයිනේ.
ඔව්.
දැන් අනිත් එක burn කරාම oxygen එක react කරලා new substance එකක් හැදෙන නිසා
හැදෙනවා. ඔව් බර වැඩි වෙනවා. ඒක හරි. ඒක මට පැහැදිලි. Okay, I'm clear on this. ඒක okay. හැබැයි මේ conservation law of conservation of mass කියලා කියන්නේ right, the reacting and the resultant. So the law of conservation of mass says, right, when this react, right, here the substances will burn in the open, and so hence you will be able to observe that mass after the reaction is lower than mass before the reaction. Mass after the reaction is lower or higher, but not this, so don't confuse. Here mass after the reaction is high and mass before the reaction is low. So what has happened? Because it has reacted with oxygen in the open air. The system is open, right? That is the problem. The make up it a false name. Law of conservation of mass is still true, but the system is open. When system is open, then system will react with the elements in the environment. The system is open. System is open in the වටේ තියෙන element එක react කරනවා. එතකොට ඉතින් වටේ තියෙන elements උත් එකතු කරලා තමයි මෙතන අපිට එන්නේ. That is the reason, right? And here another example. Few heads of matches and a boiling tube. Then put a few heads of matches in the boiling tube. Weight of the boiling tube with them. Take the weight of the boiling tube. Then heat the boiling tube strongly in an open flame until the match heads catch the fire. So after cooling, you have to measure the weight of boiling tube with its constant. You can record this and you can see now before boiling, before boiling the tube or before heating the tube, the mass of this matches, and after doing that, so that will be less than the start. The make අනිත් පැත්තට වෙන්නේ. The maker may burn කරාට පස්සේ after boiling, you can see it has less weight. අරකට වැඩි weight එක අඩු වෙලා. Right? So here iron wool was burned in activity 8.8, while decrease the mass was shown when the match heads were burned in 8.9. That what has happened? So here, why there was increase of mass when iron wool was burned? Iron wool burn කරාම mass එක වැඩි වුණේ ඇයි? ඒ වගේම match heads, sorry, this ගිනි කූරු වල ගිනි කූරු ඒවා burn කරාම after burning the heads of matches, why it is less? Why mass is less? Why mass decreases? මෙතනදි mass එක අඩු වුණේ ඇයි? මෙතනදි mass එක වැඩි වුණේ ඇයි? ඉතින් මෙතනදි දෙකම වෙන්න හේතුව තමයි මේක. So we have done the experiment in the open environment. When we have done the experiment in the open environment, it will react with the environmental metals or environmental materials like oxygen. So some might release the products to the environment and some might absorb products from the environment. The කලින් එකේදී absorb කරා oxygen. මෙතනදී මොනවා හරි release කරන්නේ නැති. ඒකයි අඩු වෙන්නේ. So what are these open systems and closed systems? Open systems are the system which can react with the environment, right? Surrounding, and that is not good. So we will not, so that environment is there, but that is not good solution, or that is not good experimental setup to decide the law of conservation of mass. So therefore we are going to use closed environments. In the closed environments, the substance cannot exchange between the system and the environment. Those are called closed environment. Let's do the experiment now in the closed environment. අපි බලමු closed environment එක මේ experiment එකම කරමු. Same experiment in a closed environment. Right? Here, a few matches, boiling tube, a rubber balloon. Now what we are going to do? Now we are going to seal the environment. Now environment is not going to change its weight, initial weight, because the environment is sealed. It cannot go out and nothing will come inside, nothing will go out. So it is sealed. Now if you burn, apply the heat to the bottom of the tube until the matches light up, and allow the boiling tube to cool and wait again. You have to measure the weight beginning, measure the weight at the end. When the matches burn, the balloon get inflated gradually. When you burn this, the balloon will get inflated. And during the reaction, the products means the results are not lost. So this is basically not, this can be called open environment. Sorry, this can be called closed environment, the other closed environment. Therefore, if you measure the weight, you can see the measurements are equal. When you measure the weight, you can see the measurements are equal. මැනලා බැලුවම අපට පෙයි measurements සමානයි කියලා. හේතුව මෙතනින් emit වෙන gas එක carbon dioxide, carbon monoxide mixture එකක් එන්නේ. ඒක එළියට යන්නේ නැහැ. ඒක එතනම රැඳෙනවා. ඒ හින්දා බර වෙනස් වෙන්නේ නැතුව අපිට මුල් බරම අවසානයට බලා ගන්න. Right, this is another example. Right? This is another example. So conical flask and lead nitrate. Lead nitrate 1 gram, water 20 milliliter, and sodium chloride 1 gram, a boiling tube. Sodium chloride, you can take like sodium chloride salt. Right? Take about 1 gram of lead nitrate and dissolve in 20 milliliter of lead nitrate. Is like it's there as a solid. You have to dissolve that in water. Then it will create a lead nitrate solution. Then 1 gram of sodium chloride to a test tube and dissolve it about 5 milliliter of water and transfer into the solution into the ignition tube. So what you need to do is you have to put sodium chloride and also dissolve this sodium chloride. 5 grams of sodium chloride you can dissolve with 5 grams of water and then transfer that. Then you have to tie the ignition tube with sodium chloride. Right here, the ignition tube, you have to tie that very well, and then like you have to suspend it inside the conical glass and containing lead nitrate solution will be, so that will basically start the reaction. So you have to tie the ignition tube with sodium chloride solution. Then you have to hang this, but after sealing this, you have to release it. Seal the conical glass here. Apply like Vaseline around the stopper. Weight the flask with its contents and slant product slant this. Then you can slowly mix 2 solutions and record your observations. So what will happen? Here lead nitrate, here sodium chloride. So what will be the result of this when you react sodium chloride with lead nitrate? Yes. So we learned few type of reactions. අපි ඉගෙන ගත්තනේ the reaction types ගොඩක් කීපයක් 4ක් ඉගෙන ගත්තා. මට මතක විදියට දැන් මගේ ළඟ slide එක මොනවා හරි වෙලා ඒක නෑ. ඒ slide එක missing. But we have learned about 4 type of reactions. I think we have written that in your book. පොතේ ලියාගත්ත නේද? Reactions වර්ග 4. I asked you to write down that type of chemical reactions. There were 4 types and I asked you to write down them. Okay, anyway, so what will be the result? What will be the result? Lead nitrate and sodium chloride.
Produce sodium nitrate.
Yeah. So the type of reaction is reaction type 2. So we just learned about type of chemical reactions. There are only few here. So I have to show you in images because slide is machine. Here, types of chemical reactions. So these are the things that we have learned, right? I hope you can remember. I asked you to write down this somewhere. Synthesis. Yes, isn't that so? We wrote this, right?
Yes, sir.
Synthesis, that is mixing, decomposition, breakdown, then single replacement and double replacement. Right? So synthesis means basically mixing 2 compounds, like you can see ferric and oxygen. It will create ferric oxide, magnesium oxygen, magnesium oxide. That is synthesis. Decomposition, it breaks down. When you heat or when you do something, it breaks down into the original or whatever it made up. It's breaking down. And then single replacement. Here C is replaced with this. In the single replacement, a replacement happens. Under the different type of reaction, we learn about the synthesis reaction, and so what is example for the synthesis reaction? It is ferric oxide example, or you can say a magnesium oxide example. That is example for synthesis. Then decomposition example. Decomposition example. Can you tell me examples that we have learned? What is decomposition? Actually, what should happen when like burning these matches? There should be something like decomposition. That is why the weight is less. When you burn, so it disappears, it decomposes. And that is decomposition. Actually, single replacement is replacing. So you can see, so this is actually a double replacement. So what you suggested is double replacement. Double replacement means when you are putting sodium chloride to the lead nitrate, so it will create lead chloride and sodium nitrate. Right? Lead chloride and sodium nitrate. That is actually double replacement, right? Double replacements, because so it will swap sodium nitrate, lead chloride will be created. Lead chloride and sodium nitrate will be created after the reaction. Right? Then actually what will happen when you measure this, the entire system, there will be a reaction, right? And note that the weights or the mass will not change. Formation of white precipitate, there will be white precipitate. That is actually, though you can see this lead nitrate and the sodium chloride, sodium nitrate will be created, and you can see a white precipitate during the reaction. But the thing is, there will be the result experiments also show that there is no change of the total mass before and after. Actually, who said this? Who explained this? That is Anthony Lavoisier. Right? He has explained that, and right, Anthony Lavoisier, he has explained that. So the total mass, or the before and after the mass. So chemical reaction, these reactants are the things that react. Mass of that will be equal to the total products. Products are the results. Reactants, please note that reactants are the things react. Right? Reactants are the inputs. You can just use pencil and write down there. These are the inputs, simply. And the products are the outputs. Products are the outputs. Here, reactants and products. products are the outputs. So the mass of the inputs and mass of the output, so the mass of the reactants and mass of the products will be equal. So that is called law of conservation of mass. During a chemical reaction, the total mass does not change. That means mass is conserved. Let's make it simple. The mass of reactants and mass of products will be equal. Or you can say during a chemical reaction, the total mass does not change. To measure that, you need a closed environment. That means the mass is conserved. Okay. 8.4, combustion. So oxygen gas, right? Basically, that is a supportive combustion, supportive substance. Combustion is basically, so in Sinhala we can call dahana කියලා කියන්න පුළුවන් අපිට, right? So combustion is basically react. So most of the things, most of these substances will react with oxygen, and so then it will create, so this is kind of the second type of reactions that we have learned. Decomposition, sorry, not decomposition, synthesis reactions, right? Synthesis reaction, because when, so oxygen is there in the air, when a combustion reaction happen, so basically it will react with the oxygen and new substances will be formed. Example, camphor, wax, sulfur, sugar, lacquer, even liquor, paper, tar, flour, petrol, kerosene. So these things, when you react, it will burn, it will combust. So we call combustible substances. But asbestos, glass, sand, rock, so these are non-combustible. These are non-combustible. That means if you try to burn, if you try to make heat, but still it will not react with oxygen, right? That will not react with oxygen. So that is non-combustible. Combustion is a reaction of combustible substances with gas, which act as a supporter of combustion, mainly oxygen. Oxygen is a combustion supported gas. So, but there are some other gases also, right? Combustible gases are, so combustible gases, we cannot dahana poshaka vayu කියලා කියනවා. Combustion or combustible gases. So dahana poshaka vayu. Okay, combustible substances. So if you have any question, you can ask. I'm not sure whether you can hear me or not. That's
I can hear, sir.
no response at all. Very silent. So why is that? Okay. The temperature at which combustible substance begin combustion is called ignition temperature. So ignition temperature or ignition point කියලා කියනවා. Ignition point එක ignition ඔයාලා අහලත් ඇති වාහනවල එහෙමත් තියෙනවා ignition coil කියලා. Ignition එක එතනදි වෙන්නේ petrol. Petrol දානවා, petrol දාලා ඉවරලා ඒ petrol burn වෙන ඒ දහණය වෙන උෂ්ණත්වය. අපි කියනවා මේකට මේ මොකද්ද මේ ජවලන අංකය කියලා. ජවලන අංකය. හරි සිංහල ජවලන වෙන්න ඕන බලමු ignition. ජවලන අංකය කියලා තමයි කියන්නේ ඔක. ජවලන අංකය. Ignition point. Basically that is the temperature where the combustible substance begins combustion in the air. Right, that is called ignition. So that is different from one to like camphor, like sulfur, sugar. Some are highly combustible, so like petrol like things. So it will, so with a very so small temperature train, not just petrol, there are some other. So with the temperature change, there can, so it can be combustible. So this, okay, then here. So you fire triangle. Do we have time to discuss that? Yes, I think we can discuss that as well. Oh, there is small part. The fire triangle. Basically, in fire triangle. So what you need to know is to start fire, we need few things. Heat, definitely, because the ignition point is the temperature where it begins combustion. So the heat is essential factor. Fuel. Without fuel, it's not possible to. Without fuel, it is not possible to start fire. And the oxygen. So that is basically that is combustible gas, combustion supportive gas. That is oxygen. When you have all these three, right, in the fire triangle, when you have all these three very well, then it starts a fire. But if you kill or if you remove one fact, for an example, oxygen is removed, then the triangle is not complete. Therefore, you cannot see fire. The heat is removed. So this is important because when firefighters, if you want to become a firefighter, or if you want to become like, if you want to stop fire, especially this extinguishers, fire extinguishers or firefighting people use these fire extinguishers to extinguish the fire, you need to remove one fact. But just removing one fact will, right? So then what are the methods? Why we put water into fire? So what fact will be removed? Is it heat or oxygen or fuel? So what will be affected? Heat. When we put water into fire, what will be, which fact will be affected?
Heat.
Heat. Yes, we can cool it. When you put water, maybe we can use sand or wet gonies or water. When you put it to that, then the heat will be controlled. So then another thing is we can, so it's difficult to remove oxygen, but we can remove fuel part. So the easiest way is controlling the heat. Easiest way is controlling the heat. Right. Another, so when you put, like when you cover this, like when you fully cover this, that can happen. When you fully cover this, this air factor can be removed. And I think, yeah, you can remember how we have extinguished a candle light just using a glass. When you put the glass, the oxygen will be over after some time and it will be extinguished. Right. Then, so these are some fuels that you can think of. Like, so when so I couldn't tell. So when you see a fire, right? So one thing is you can reduce the temperature that we have discussed, and also, so when, for an example, when a cloth catch fire, the most suitable thing is stay calm without running or roll on the ground. Right? More extinguish, roll on the ground. This helps the break connection between the air. Right? So they're supported, like when you roll over the ground, when you, but if you try to run, there are bima dige roll වෙන්න ඕන. බිම දිගේ roll වුණාම අර එයා එක්ක තියෙන සම්බන්ධය. දැන් අපි හිතමු යටින් ගිනි ගන්නවා. එතකොට බිම දිගේ අපි පෙරලෙනකොට යට ගින්දරත් එයත් අතර වාතයත් අතර සම්බන්ධතාවය බිඳුනම ගින්ද නිවෙනවා. හැබැයි අපි දිව්වොත් එහෙම තව එයා වැඩියෙන් හම්බ වෙනවා. ඔක්සිජන් වැඩියෙන් හම්බ වෙනවා. එහෙම වුණොත් තව ෆයර් එක වැඩි වෙනවා. Here, when clothes are on fire, you should never run. During the running, more and more oxygen supplied to the fire, so it spread faster. It spread very fast. So running is not a solution. Right? Same method cannot be used to extinguish all the fires. The nature of the fire should be identified, and then appropriate method should be selected. Fuels. Fuels are substances to generate heat and energy, light, and examples of fuels: firewood, coconut husks or coconut shells, wax, kerosene, petrol, diesel, coconut oil. These are liquid fuels. These are solid fuels. There are gas fuels also. LPG, coal gas, biogas. These are gas fuels. Right? So almost every fuel will get carbon and hydrogen. Therefore, in the combustion process, it will break down into, or it will create carbon and hydrogen related. Here, this is small experimental setup to see that. Right? Here you can see anhydrous copper sulfate, nirjaliya copper sulfate, anhydrous copper sulfate. So you don't have water, so it is color, its color is blue. Sorry, not blue. The color is white because it is anhydrous copper sulfate. And then you can see, so it is placed in a water, and then here you have seen lime water. Lime water is basically we can colorless. Right? Then here a candle is light now. When the candle, when the wax burns, candle wax burn, if candle wax burn වෙනකොට අපි බලන්නේ මේකට මේ carbon hydrogen මේ candle wax වල තියෙනවද කියලා. Every fuel contains carbon and hydrogen කියලා අපි කියවනේ. If there's hydrogen, so that will produce water most of the time, H2O. If there's carbon, it will produce, because hydrogen will be reacted with oxygen. Hydrogen oxygen එක ප්‍රතික්‍රියා කරලා H2O වතුර හැදෙනවා. ඊළඟට carbon oxygen එක ප්‍රතික්‍රියා කරලා carbon dioxide හැදෙනවා. Carbon will react with oxygen, carbon dioxide is created. Hydrogen will react with oxygen, two hydrogens and oxygen together, H2O, water will be created. Right, here you have anhydrous copper sulfate. No, when the candle light up, and you can see the candle, this is going through this U tunnel, and then what will happen? Right, so slowly this will become blue color. So how it become blue? Because it will contact water. The මෙතන එළියේ තියෙන water නෙවෙයි, මේ ඇතුලෙන් යන water. කොහෙන්ද water තියෙන්නේ? මෙයා burn වෙද්දී හැදෙන water. When it contact with the water, this anhydrous copper sulfate will become blue color. එමීට ඕක නිල් පාට වෙනවා. Anhydrous copper sulfate is basically white color. When you boil, right, it will slowly convert to blue color because of the water vapor. And the next thing is, this will become white color. හුණු ජලය මේක ඔයාලා පොඩි කාලෙත් කරා. හුණු ජලය අරගෙන ඒකට පිම්බම ස්ට්‍රෝ වටයක් දාලා පිම්බම ඒක කිරි පාට වෙනවා. හේතුව මොකක්ද? In your exhale gas, there's carbon dioxide. පිට කරන ප්‍රාශ්වාස වාතයේ carbon dioxide තියෙනවා. ඒ හින්දා lime water වලට straw එකක් දාලා පිම්බම lime water පාටක් නැහැ, සුදු පාට වෙනවා, කිරි පාට වෙනවා. මොකද මේ carbon dioxide ගිහිල්ලා අරකේ දිය වෙනවා. lime water වල දිය වෙනවා. එහෙම දිය වෙනකොට ඒක සුදු පාට වෙනවා. Here the activity indicates when the candle burns, the water here I couldn't tell that. So YouTube contains, YouTube business, this YouTube, right? This YouTube contains anhydrous copper sulfate. While boiling, the tube contains colorless lime water. When candle is lit and aspirator is set to work, you will observe white anhydrous copper sulfate turns blue. Also, you can see in that the lime water turns milky or the white color. So white anhydrous copper sulfate turns blue because of the water, and the lime water turns into milky due to the carbon dioxide gas. Therefore, you can decide. So in this process, water and carbon dioxide will be created. Basically, water vapor. Right? In the activity indicator, candle burns, water and carbon dioxide gas produced. Just combustion fuels. Right? Combustion fuels, water and carbon dioxide gases are produced as the products. Combustion of fuels. ඉන්ධන දහනය වුණාම ජලය සහ ජල වාෂ්ප සහ carbon dioxide හැදෙනවා කියන එක තමයි මේකෙන් අපි ඉගෙන ගන්න. Okay, about the candle flame, let's learn that is very small part. Let's learn that next day, right? Because there are some activities. So I'll give the note next day. Right? Today I just wanted to do that because like we missed one class. Okay then, good night. See you next week.
Okay, sir. Good night, sir. Thank you, sir.